Good afternoon. I'm coming to you from my office. It's been almost 2 years since my last COVID-19 data update, and I'll show you the reason for that because it's been getting better and better over the past couple of years, at least when it comes to the initial COVID infection. So we have what we have to talk about on August 2023. There's two new things that came out, a couple of new studies that include one of a test that will actually tell you if you are immunocompromised. So I'm kind of interested to tell you about that, and also some evidence of how broad your immunity might be. You might even have antibodies against MERS if you have been vaccinated and or infected by this point. So let me tell you about these things. November 12 was the last time, 2021, when I did one of these data talks. And these are my three questions. Where are we at right now? I'm going to show you. Why do older people get so much sicker was my second question. And it's interesting because we have the same kind of question showing up now, but better definition of it. We know that older people got so much sicker because their older immune responses were more susceptible to the virus. How do we identify, beyond just saying the age of the person, how can we identify those who are truly immunocompromised? And I'm sure you also know people who are struggling with various forms of immunocompromisation. How do we say that this person should be okay if they're infected by COVID, and this person needs to be more careful, needs to distance when there's a wave going on and things like that? And there's actually a pretty simple test that might be able to tell us what that is. So I'm going to tell you about that. The first question is, where are we right now? And this is a global view of several Western nations that are showing the waves that we've been through since 2020. And you can see that 2020, 2021, and even the Delta wave for the blue USA line shows up as one of the ways in which America, USA, was hit particularly hard during that wave. But then we have the Omicron wave that came around the turn of the year from 2021 to 2022. And since then, you notice that for the whole globe, you have much lower rates of COVID patients in the ICU. Now, I'm going to be focusing on this initial part of the disease right now. A little bit more about that at the end of the talk, about the other aspects of this disease. This is the USA line. It shows the Delta wave was really a USA-specific wave. That was, and I don't want to gloss over how that was a pretty severe wave for our country, and you can see how it stands out globally. But then Omicron, we experienced the Omicron wave globally, and then since then we've had waves still where people are still ending up in the hospital, but it's much lower. It's much more like the flu now. We have built our immunity wall as a population. And again, I'm talking about population level talks about right here. What can we say for the majority of people in the majority of situations? So one of the questions is, there are still waves coming by. We're handling them much better. Could there be a variant that will get around our defenses? Possibly. And I want to say, what are the chances of that, and what will we be able to react to when we see something new going on? We're at such a low baseline right now that just saying that something's going up does not say it's going to be like 2021 all over again. We are in a different paradigm now because we have put a lot of work and sacrifice into building our immunity against this virus. So the question is, when a new wave hits, how will we tell how bad it's going to be? The real answer is we don't know, but we can look at the array of existing variation among coronaviruses, and we can say, how much do our existing antibodies developed against this one coronavirus, how well do they protect against other coronaviruses? And here's the family tree of coronaviruses. This is the family that is all the SARS-CoV-2, the COVID-19 coronaviruses. And then you have SARS-CoV-1 that caused the original SARS epidemic more than a decade ago. And you can see that there's a reason why it's called SARS-CoV-2 and SARS-CoV-1. On the family tree, they are very close to each other. This is genetic relatedness, by the way. But you can think of it as SARS-CoV-1 and CoV-2 are siblings. Out here you have their cousin, MERS-CoV. And that is the one that you might have heard about. There was a bit of a panic around, I think it was the World Cup, that people were worried that MERS might be spread by the World Cup. I want to point out that did not happen. And part of the reason why it did not happen is even if there was an opportunity for MERS to get into the population, MERS is on the same family tree as the SARS coronaviruses. And so it's a more distant relation, but it is a relation. And the question is, how well can our antibodies against SARS-CoV-2 bind to the surface proteins of MERS-CoV? So we can look at those, and I've colored them from red for SARS-CoV-2 sort of down the rainbow. When we get out the green, we get out to the common cold beta coronaviruses, HKU1 and OC43. Actually, on my other videos, I look at these a little bit, talking about cross-reactivity. And the reason why there's more cross-reactivity, you can see they're on the same family tree. There's two other common cold coronaviruses. Those are the alpha coronaviruses. Those are going to be colored in blue. Those are the 229E and NL63. And again, my other videos, we actually investigated the cross-reactivity potential between these. And we found that there was some potential, not 100%, but significant, more than 10% overlap between the sequences and therefore the immune responses that you develop to these different viruses. And so I think we were helped. Maybe we can quantify this someday, but I'm pretty sure that we were helped somewhat against SARS-CoV-2 because we had some existing immunity, not a lot necessarily, but some, from the common cold coronaviruses that were already in circulation. Again, those are green and blue. And then we have more distant coronaviruses. Those are the gamma and delta coronaviruses, and I'm going to color those purple. Those are at the other end of the rainbow from SARS-CoV-2. And the paper I want to show you is from Florian Kramer's group, and it's this is the paper right here. You can go and look it up yourself. And it's a really simple paper. It's actually nicely short, because all they did is they took freezer cases of serum that were collected from patients, either before the pandemic, after they were infected, after they were vaccinated, or after they were both vaccinated and infected. And you have these different categories. So these are actually antibody responses that are right after the infection or vaccination event. Now, of course, vaccination is just with the spike protein. So the question is, the spike proteins can be rather different, especially because it evolves more quickly, it's more exposed, it's the biggest target for us to go after, and the virus has the evolutionary pressures to get away from our antibodies as a result. So there's an arms race between us developing antibodies and the virus developing new variants. So all I want to say is that this is a pretty quick and dirty kind of test. You take antibody sera from different points in time. You take spike proteins and you make those recombinantly in bacteria, same kind of thing that I do in my lab for different kinds of proteins. And it's just spike versus serum. You see how much it binds. This is about breadth, not depth of response. But that's the question I want to ask if you're asking questions about cross-reactivity and things like that. So what they conclude is, this is in the abstract, our population immunity against SARS-CoV-2 has been profoundly changed and broadened. And not just against SARS-CoV-2, to a certain extent against all coronaviruses. The more related to SARS-CoV-2 it looks like, the better the protection in general. And of course, you have the common cold coronaviruses, which we have already developed some kind of protection for, even before the pandemic. So remember, this is just for antibodies, and these are the ones that are expected to be less cross-reactive, because the cellular immunity, and I have other videos about this, is going to be more cross-reactive, but it takes a longer time to kick in. So check out my other videos if you want to know more about T cells. Today we're talking just about antibodies. And I just want to keep in mind there's always something we want to say with a quick thing like this. Not all immune responses are good or wanted immune responses. there's some cross-reactive responses that can be bad, and so you can say that against this study. But I can say we can correlate the responses that we've had against the declining waves of SARS-CoV-2, and we can say, on the whole, our immune system is doing what it's supposed to. It's being able to come up with a cross-reactive response that works against SARS-CoV-2, and we can also see what other viruses, maybe that's never even seen, what other related viruses is it able to recognize. So let's check it out. Here's the graphs. And I'm going to color these the same way. So in pre-pandemic serum, basically the higher up the bar goes, the more antibody binding to that spike you have. And you can see pre-pandemic, you don't see any antibody binding to any of these spikes to SARS-CoV-2, CoV-1, or to MERS. Whereas for the common colds, the green and blue, you actually do see some binding, and this is what you expect. And then for those more distant, the purple ones, you see no binding at all again. Okay. Then we had infection and vaccination, where our immune systems got exposed to the spike over and over again, but the spike's a moving target, right? So the question is, how many different kinds of spikes can our immune system that's been trained against the one original spike or whatever we infected or vaccinated, how does that work? How broad is the response? So here's the SARS-CoV-2 and SARS-CoV-1 for people who have convalesced from infected. These are previously infected people who got better and healed from the disease and learned to recognize it. And you see that on the whole, there is a lot of response to SARS-CoV-1 in orange. In the yellow-brown, you can see that there's somebody who was infected has about, by this measure, it's 75% of the response against MERS, which they've never seen. I can guarantee you, unless they've been in the Middle East around camels or something, I'm pretty sure that you've never seen the MERS spike, and yet your immune system will respond to it just from a SARS-CoV-2 infection. Here is the common cold viruses. These bars are, if anything, a little higher than they were before. And there's even some highness on the most distantly related coronaviruses, this Gamma and Delta. You can see they're up around 50%. Okay, what about someone who has been vaccinated but not infected? Well, you see here the same story. If anything, the MERS is a little bit higher. SARS-CoV-2, CoV-1 are high. MERS is almost as high. Common colds are high. There might be some added protection to that NL63 common cold. And there's even a little bit higher for the for the Gamma and Delta. So if you got a third shot, the bars, if anything, they just go up some more. And so you can see there's a lot of black bars there. And again, 50% for the most distant Delta and Gamma coronaviruses. Far more distant than MERS even. So what about and honestly, most people are probably in this category, infected and double dosed with the vaccine? You see these lines go all the way to the top for all these different things. And so I see this MERS immunity is in place, and you even have a little bit of Delta and Gamma immunity here. 3 times, again, it's definitely not doing harm to your antibodies, but they're already so far up. That's the point by this assay. And this assay might be pretty sensitive. We don't know exactly how it corresponds to immunity, but I've got a paper that says that it's probably significant. And so it's good news. And the thing that most impresses me is the immunity against MERS itself, and even some immunity against those far-flung purple ones. But does this really matter? This is just antibody against just spike. There's a lot more to the immune system, and there's a lot more to the virus. Well, here's a really cool paper, and this was brought up by Kramer himself on a tweet, and he says that this paper has been overlooked. They went back and they looked at nursing home patients, older, more frail, more immunocompromised in general, and they were trying to see, well, when a new variant came into play, Could we tell who was going to be protected or not from a simple antibody spike binding assay? It's pretty easy to make just a spike. It's pretty easy to collect sera and to measure antibody binding. And it turns out that yes, this was predictive for a new variant sweeping through the nursing home and infecting the patients. The patients who had antibodies already, before they had time to develop new antibodies, their existing antibodies bound to spike, they would be protected on the whole. And so you could predict that they were already protected, and the ones who didn't have antibodies that would already protect them, those are the ones that you could protect more. And this is really a good thing to me, because it tells us, number one, a lot of times the antibodies that exist will work against new variants, and also it will matter. It will mean that those people are protected by their own immune systems already, and we can identify those who are not protected so that we can protect them further. And that's one of the main things about this. We've got an immune system on our side, so this is one way that we can tell if the immune system's actually working or not. So immunocompromised is a weird category. Your immune system is really huge, and so maybe you have a T-cell deficiency, but it's not going to matter that much to your antibody response. There's some relation, don't get me wrong, but I want to say that you can have a good antibody response in the absence of other branches of your immune system being compromised somehow. How can we tell rather than the general thing of I have a problem somewhere with my immune system? This actually comforts me because it says that maybe a simple test might be able to say, hey, this person is actually protected, probably, and scientifically speaking, we can say probably only. But they're protected from the severe fatal COVID-19. It's an interesting question of how does this work, because these are not necessarily strongly neutralizing. They don't necessarily physically block, but they alert the immune system in other ways. And so we can get into what all this means. NK cells, macrophages, complement, other parts of the immune system are going to be kicking in, because this is not making new antibodies, but this is existing antibodies. And because there's such a broad base of reaction, the antibodies you have are good against a lot of related viruses. That means that new variants are going to have that much harder of a time getting through your wall of immunity, and that the simple test might be effective. So my conclusion is I want to give this data update as a positive data update. We are winning the fight against this first form of attack, keeping people out of the ICU. There's the graph for how it's working on a global scale, and there's some hope that we can say on the individual scale, how can we prevent the initial wave of mortality? Now, of course, this doesn't say much about whether people will get long COVID, but just like I want to say that we need to define immunocompromised, we need to be scientific and we need to define what long COVID is. Even the term long COVID is an umbrella term for a lot of different things with a lot of people with a lot of different immune systems. And so to treat it, we need to define it. And we need to be as rigorous about this as we were about the immunocompromised. I just want to give you a little bit of a data update, and I'm happy to be able to make this one mostly positive. And I want to encourage scientists to keep working on the long COVID aspect of this as well. All right, so hopefully maybe my next data update will be more good news. In the meantime, I hope you carry on and protect yourself and those you love, but know that your immune system is protecting you too. Until then.